Okay, so hey guys, this is the part 3 of binary tree series, and so today we're gonna solve the question number 104, maximum depth of a binary tree. And so question is in front of you. You can pause the screen and read the question. So here we see the given the root of a binary tree written it's a maximum depth, and a binary tree maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So you see there is a root node which is having a value of 3, and this is the leaf node, we can say that 7, which is having a value 7, or either you can say the 15 also. And in the input we see 3, 9, 20, null, 15, 7. Null is just because you see if 3, 9 and 9, 20, then after 20, 15, 7. Okay, null means nothing. The a node pointing to the null means its container nothing, either it's on the right value or on the left value. So what question says to us, we need to calculate a maximum depth, and we just need to apply the value of a height in this question also. So here we see if you draw the row above the node 3 and write a value equals to 1, then after you write the row on the above the node 9 comma 20, you see the root left comma root right, this contain 1, 920 contains 2, 157 contains 3. You just have to draw the layers to understand this question. There's nothing any a big problem in this. You just have to write the layer. So this is the first layer, 920 is the second layer, and 1577 is the third layer. That's it. And for the example 2, 1 null 2 means if you have only, let's suppose 3 and 20, 3 is attached with the 20 node, then you have to write the height of the tree. So this is the first and this is the second layer, means the answer is on, this answer is 2. That's it, and I hope you understand. So let me see the code. Okay, so let's say apply the first condition where we check if the root is a null, then we return the value 0 or any if you want. Okay, so if root is equals to null pointer, means is denoting to nothing, then we just have to return the value 0 to the compiler. And then we just adding the both the left depth and the right depth to calculating a height of a binary tree. So write left depth equals to max de ATH. We just have to see the spelling of these functions. Because of this function are written in the wrong manner, then there's no point of to write this code. And after writing the max depth function, we just apply the root left here. Okay, and then sorry, semicolon, and for the right depth we write the right depth equals to max th, and in this function we just try to have root right value story. Okay, after all that we just need to return the value which contains the both the sum of the right depth plus left depth plus 1. 1 is just because it's contain the root nodes. If we see the maximum a line which maximum a depth, to calculate the maximum height of the tree, we just need to check if your tree is passing to the root node or not. There are the two ways to calculating the sum of trees, sorry, a height of trees. Either you can go through the root node or without root node. So in this case we just have to go through the root node for the better a clarification. And after this we just write the max of left depth and a comma right depth, and then just we add the root node value which is 1, and hope this code runs. And just we write try to run it. Sorry, it just take a okay, we don't apply the int data type, it just need int data type, because if you don't write a data type in of any variable, then there's no point to write the code again. You just need to focus on the silly mistakes. Okay, now we run this, and yes, it's run. So hope you understand this code in the very optimal approach. And this is for today guys, so hope we meet in the next video. Bye.